Okay, our first example that we're going to do from chapter 2, we have a force of 800 newtons that is acting at an angle of 35 degrees drawn in this way from the vertical. O is our origin there. And you want to write this as a vector quantity. So write force F as a vector quantity. Well, what does that mean? What do we mean by write it as a vector quantity? What would that look like? What did that look like in our last example?
Y component?
It's going to have a y component and what else?
X component.
An x component. And what would it look like when you write it out? So think about our last example where we had that vector v. It's going to have a scalar component in the I plus a scalar component in the j. Okay, so how do we write that out? So here we go with our sines and cosines and loving our trig that you've had many, many times. Okay, so how can we get the x component? Let's draw it here. And I really do think it's helpful when you're starting to do these problems to draw it out. I know most of you are working on a screen, but draw it out on your screen or on a piece of paper. It will really help you just to get the sense of what we're doing here. Okay, so we have an fx. And there's an fy. So if I am doing vector addition, I know that the x component plus the y component has to get me to the end of that vector. So what do you notice already about the x?
It's negative.
It's going to be negative. Okay, so how are we going to get these quantities? So how do I know what fx and fy are? The way it's drawn here, it's a little bit easier to draw fx here. And, I'm sorry, draw fy there and fx here. Okay, so what is fx? Well, let's look at the sine of that angle. Sine of 35 is going to equal what? Sine of that is going to equal which component?
F of x.
Fx, the scalar in the x direction, over what?
The total 800.
Over 800. And then the cosine of 35 is going to equal what? Fy over 800. So you just have to pay attention to the way that it is drawn in the problem. Okay, so we're very used to looking at xy axis, and we have a force that's drawn like this, and we have a theta here, and we know that this is fx, and this is fy. But just be aware that you might have other configurations where the angle is given to you in a different way. So it's not always going to be sine for the fx and cosine for the fy, or vice versa. You have to actually look at the problem. Okay, so then we can pretty easily solve this, and we get fx equals 459 newtons. Make sure you have your units, and fy equals 655 newtons. So then if I'm going to write this as a vector quantity, I say that F equals 459 in the I, and you can put the little hat over there if you'd like, plus 655 in the J, and is that enough? Is that right?
Probably not. No,
Because I wouldn't ask you if it was right? All right, what's wrong there? Yeah.
The x direction should be negative? Yeah.
This, remember, we had to have a negative here. Okay, what else is wrong? There's one other thing that's wrong. Why you would get points taken off.
No units.
There's no units, so we got to put the newtons in there. Okay, that's it. You do have one of the problems are like this on your homework or quiz. I forget which one.